So this is officially the third lecture, but the syllabus we are starting today itself.
Yes.
So the topics will be the first topic in your syllabus, that is the electrical batteries, and we are going to go as per the syllabus. So the topics are as given in your syllabus, that is principles on construction of lead acid battery, characteristic of batteries, rating capacity and efficiency of batteries, then a few charging methods of battery you will see, and finally constructional aspects of alkaline battery. So we can see that the first topic is lead acid battery and the last topic is alkaline battery. So there is a difference between lead acid battery and alkaline battery. So lead acid battery was initially invented, and nowadays there are a lot of other technologies for power supply. And alkaline battery is or NiCad battery, as we will see. So that is a newer one. We'll see all these topics today, and time will be almost 50 minutes. So there are around 20-21 slides. Let us see how many we can go through. So requirement of a battery in a vehicle. So what you can find is battery is the main source of energy for any vehicle. Okay, so there is engine. So engine is actually run by the fuel, and there might be another alternator which is also a generator inside a vehicle. So when engine and alternator both are not running at the time, battery is the main source of energy inside the vehicle. And battery has a number of requirements. That means some of the characteristics we can expect from the battery if it wants to be put in a vehicle. So first and foremost characteristics of a battery is that it should provide the storage and be able to supply the electricity quickly enough. So that word is very important. We have discussed this 5 points previously also. So first thing is it's a power storage, and second thing is battery should supply the energy quickly enough to operate the vehicle starter motor. So during starting, battery has to withstand a jerk, or we need a very huge amount of energy at the starting of the car. And when the car starts or vehicle starts, at that time the other whatever generators are there, they actually take up or they actually share the energy requirement. But at the starting, it's only the battery which is helping the vehicle to start. Yeah, so these are the two very important points. One is the power storage, another is the quickly enough. So the battery has to supply energy quickly enough. And second one is whenever there is parking light, and whenever there are other lights and all in a car, so they should be supplied very fast. Okay, and all those supplies come from battery itself. So the battery should allow use of parking lights for reasonable time. Uh, and these are the main 2 points that the battery has to do. Other than that, the battery has to allow the operations of accessories when the engine is not running. So I gave an example that some senior is sitting in the car, you want to go to a shopping mall and pick up few things and again come back. So you have to keep the AC on, you have to keep the sound system on, though the engine is not running. So at that time, the battery will be supplying all those electricity, whatever requirement are there. So that should be supplied by the battery to the all these accessories. Okay, so sound system, maybe light, child, then at the time ACs and other thing, it will be supplied through battery. So this battery acts as a swamp or damp out fluctuations of the system voltage. So there might be engine running, there might be alternator running, all those things. So sometimes there might be some fluctuations in the energy. Sometimes there will be a sudden requirement of energy, or at that time the vehicle can access all those sudden energies from battery. So this is a point which will be discussed later on, because it depends on case exactly during which instances or why sudden fluctuations are created, and why suddenly there is a requirement of a steep requirement of some kind of energy, and battery will be supplying that. So this fourth point, to act as a swamp or damp out the fluctuation of system voltage. So this will be discussed later. Fifth point is the to allow a dynamic memory and alarm systems and to remain active if the vehicle is left for a longer period of time. So not every vehicle is used every day. It happens that vehicles are sometimes for some family and all. So there is a main vehicle and there is a standby kind of a thing. So that standby vehicle is used maybe once or twice in a week, or maybe for half an hour or so. So in that case, if the vehicle is left for a longer period of time, at that time the battery has to be very good, and whenever there is a starting thing, the battery has to start it. Okay, so these are the mainly five requirements, or these are the mainly five importance of the battery. And there is a big paragraph, and this paragraph is very important, so a lot of details are there. It says that the first two of the above listed, I told you that I have shown it in a green. So this first two are the main point and major part of the criteria used to determine the most suitable battery for a given application. So depending on application, the usage of battery changes. So the lead acid battery in various similar form has to date means up to date, proved to be the most suitable choice for vehicle use, because it can supply to a DC series motor. Lead acid battery can supply very huge amount of charge in a very short amount of time. Okay, that's why lead acid battery in various similar forms has to date proved to be the most suitable choice for vehicle use. This is particularly so when the cost of the battery is taken into account. So comparatively, in less price, the lead acid battery is giving us very big performance or suitable performance. Final requirement of the vehicle battery is that it must be able to carry out all the above listed functions. That means these five functions over a wide temperature range. So this is another requirement, that is the battery should be able to function over a wide temperature range. And the things that I have underlined, so you have to understand or remember all these things. So here I have underlined the temperature range for which the battery must work, and the temperature range is minus 30 to 70 degrees centigrade. Okay, so this is the battery range, that is minus 30 degrees centigrade to 70 degrees centigrade. Generally whatever vehicles we are seeing or battery are designed, it should be functioning between minus 30 to plus 70 degrees centigrade. So almost over 100 degrees centigrade range, the battery has to function. This is intended to cover cold starting condition. So this is something which we have to understand. What is the cold start condition? So if the temperature is very less at that time, the temperature in the ambience is very less at that time, the battery will require much more energy compared to the ambient temperature is high. So if the car has to start at with vehicle ambient temperature at minus 20 degree, in that time it will be requiring more amount of energy compared to if the ambient temperature is plus 30 degrees centigrade. So cold start is a very important condition, that whenever the ambient temperature is very less, then also the car should start, and then there will be a bigger jerk given on the battery. Okay, so this is intended to cover very cold starting conditions as well as potentially high under bonnet temperature. So these are two extreme things. One is cold start, that means ambient temperature is very less. That time also the car should start properly. And second one is under bonnet temperature, that means inside the bonnet temperature is very high. That means ambient is also very high temperature. That time also the car should start very properly. That means these are the two ends, that is minus 30 degrees centigrade to plus 70 degrees centigrades. These are the two extreme ends. Okay, so in this also the car should start very properly, and the battery has to support the starting of the car at that time. There will be a lot of points, so be very careful about the header of the slides and then the discussion. Choosing a correct battery for a vehicle. Okay, so what are the conditions? And these are the small questions that will be asked during your IA as a quiz. So please prepare the slides well. The slides will be shared with you in the Google Classroom, and the lecture will be uploaded in the YouTube and will be shared with you. So what are the correct parameters for choosing a correct battery for any vehicle? The first is the ability to power the starter to enable minimum starting speed under very cold condition. So even if the ambient temperature is very cold, then also the battery should be able to supply the starter, so that the starter can start the car or vehicle with minimum starting speed. So when the car is started with minimum starting speed, then the engine and alternator, all other things, they are charged, they are into action, and they also share the main chunk of the power requirement. But that initial thrust, that initial starting part, that has to be given by the battery. Number two is the expected use of battery for running accessories when the engine is not running. So accessories means there might be light, there might be AC, there might be sound system. So all those things are accessories which require power. So if the battery is not there, if the engine is not running at the time, the battery should be running all those accessories. So these are the two main conditions which are required. Now you can check, this is a very important diagram, you have to understand this, and you have to produce this in the exam as it is asked. So this is PCSL. CSL means cold starting condition. Okay, so whenever you can see this graph, so x-axis there is the temperature, and y-axis there is the percentage power which is delivered. And you can see there are two graphs. One graph is starting at around so this is 100%, so this is 0% power, and this is 100% power. So one graph for temperature of 0 degree, it is requiring, so for temperature of, this is -20, -10, this is 0. So when the temperature is almost -25 degrees centigrade, these are the ambient temperature, at the time we are requiring almost 90% power for starting the car. Okay, so just check, this is starting power required for engine. So this graph, whichever is exponentially decreasing, that is the starting power required for engine. And this increasing power is available power from the battery and starter. And one thing we can check, that as the temperature is increasing, the available power from the battery is also increasing. So always try to understand the graph. So this is ambient temperature, x-axis, y-axis is percentage power. As temperature is increasing, battery is delivering more and more and more power. That is one thing you have to check. And as temperature is increasing, at the time requirement of power to start the vehicle is decreasing. So when the temperature is -25, at that time we are requiring almost 85% of the power for starting the car, or starting power required. Just check, this is starting power required by engine. So when temperature is -25, at that time you are requiring almost 85% power for starting the vehicle. So this is called cold starting, but starting limit is coming somewhere here where these two graphs are crossing, because at -25 the battery can give this much power, almost 50% power, but the battery is requiring 85% power. That means whatever power is required for starting, that much power is not supplied by the battery, or battery cannot supply that much power. Okay, so at -25 degree, the car cannot start at cold. So cold starting cannot occur at -25 degree. But cold starting can occur at -20 degree, because at -20 degree, the battery is giving almost 50% power, and cold start power, so PCSL. So this is the starting limit, this is the crossover point. So wherever these two graphs are crossing over, that is the minimum temperature at which the car can start. This is a very important graph which you have to understand, and in the book of Denton, I have shared it with you. You'll be finding all the related details in the 5th chapter in the book of Denton. And this is not explained actually that way, but from the graph, it is understandable. So exactly at -20 degrees centigrade, the car can start, and higher temperature also car can start, because if you see somewhere at 0 degree, 0 degree centigrade, the battery can give you almost 62 to 65% power, and required power is only 10% or 20%. Okay, because this is the required starting power, and this is the available starting power. So at higher temperature, 0 degree, starting of the car is not a problem, because at that time available power is around 62%, and required power is almost 20%. So when available power is more than required power, car will start very easily. But just check at -25, available power is around 45 degrees centigrade, required power is 85%, not possible, the car cannot start. So what is the minimum temperature the car can start? That is -20 degrees centigrade. Here The available power is 50%. Here the required power is also 50%. So this decreasing graph tells us that as the temperature increases at the time, the starting power requirement by the engine it reduces. And as the temperature increases, the available power from the battery it also increases. And what is this point? What is this point? This point is power for cold start. So this thing is called as cold start limit, and this is the power for cold start limit. And how much is the power for cold start limit? It is 50%. So I might draw some graph like this with a different scale and all, and I might ask you what is the cold start limit. So that might happen in the IA. I'll be drawing a different kind of graph. I might show this crossover at around 30%, and I'll ask you, and temperature I might show as minus 30 degrees centigrade, and I can ask you what is the cold start limit. So cold start limit is exactly the point at which the available power and the starting power they are crossing each other. Okay. So I think this graph is clear, right? Any doubt on this graph? If
Sir,
yes or no, please let me know in the chat box if the graph is understood, because this is very important.
sir,
If there is any doubt, you can ask question, or if there is no doubt, you can write no.
sir, where
Just
the
write
graph
yes
made
or
there
no.
is,
Nitin, you are asking something, right?
yes, sir.
Yeah, so ask.
Sir, where the graph made that is power and temperature that is starting power, sir.
I could not understand your question. Can you repeat again?
Sir, where the both lines meet that is the starting power or what?
Where the both line met. So this is a point. See, this decreasing exponential graph is the required starting power. Okay. And as we
Okay,
find that as the temperature is increasing, the starting power requirement is also decreasing. Just check. This is 20. So how much is this temperature? Can you understand this is 25 degrees centigrade?
yes, sir.
Okay. So how much is the starting power required? It is 10%, 20%. So middle of that, around 15%. Is it
Yes, sir.
understandable? So if the ambient temperature is 25 degrees centigrade, at that time, starting power required is only 15%, 1 5. Okay. So as
Okay, sir.
ambient temperature is increasing, at that time, starting power requirement is decreasing. The same thing at minus 25 degrees centigrade. How much is the starting power required? It is almost 85 degree, 85%.
Okay,
Is it understandable?
yes,
Okay.
sir.
This is this graph. So at minus 25 requirement is 85%. At plus 25 requirement is 15%. So this is this graph, decreasing graph. Now check how much is the power available. Okay. So power you are getting from battery. So this is the available power from battery. So at minus 25 degree, how much power is available in the battery? It is plus 45%.
Yes,
Understandable?
sir. Yes, sir.
Plus 45% is available and requirement is 85%. Can the car start?
No, sir.
Now it is clear. So
Yes, sir.
when the what is the temperature at which these two graphs are coinciding each other or cutting each other? Exactly at minus 20, if you see, at minus 20 available is 50%, required is also 50%. So exactly this is the point, or this is the minimum temperature at which the car can start. Is it
Yes,
understandable?
yes, sir.
Question is at minus 10 can the car start? At minus 10 degree can the car start? At minus 10 the power requirement is almost 30%. At minus 10 degrees centigrade the power available is almost 55 to 60%.
Okay.
Understandable? So can the
Yes,
car
sir.
start? Answer is yes.
Yes,
This graph is clear.
Yes,
yes, sir.
yes,
So what is the starting limit? Starting limit is exactly that point where these two plots are crossing each other. And we have to see starting limit is the temperature and what is the temperature at that. So as per this graph, minus 20 degrees is the minimum temperature at which the car can start. Less than minus 20, the required power is less than the, sorry, supplied power is less than the required power. So less than minus 20 degrees centigrade, the vehicle cannot start. Greater than minus 20 degrees centigrade, any temperature, the battery power will be greater than the required power. So greater than minus 20 degrees centigrade at any temperature, the vehicle will start. Is it clear?
Yes, sir.
Naveen, now? Okay.
Yes, sir.
And both these graphs are exponential. This is exponentially decreasing. This is also exponentially increasing. So you have to remember this characteristics of this graph. So this is exponential. So e raised to minus something of t. So maybe e raised to minus 0.5 t or something. This is the graph. Okay, so I'll just explain this graph. So it says figure shows the characteristic graph of a battery comparing the power required by the starter and the power available from the battery plotted against temperature. I think I have told you that. You please mute your mics whenever it is required. You unmute and ask. Otherwise, you keep your mic muted. Okay. So the point at which the lines cross is the cold start limit, PCSL. So PCSL is a name I have given. P stands for power and CSL stands for cold start limit. You also can use the same thing in your answer, either assignment or journal or whatever you are doing. So PCSL you can write. So this is power required for cold start limit. So how much is the power for cold start limit? It is 50% at minus 20 degrees centigrade. European standards are generally 18 degrees centigrade as the cold start limit, and a battery to meet this requirement is selected. So research has shown that under normal cold operating conditions in the UK, most vehicle batteries are on average only 80% charged. Okay, so here we are having 50%, and UK actually they're using 80%. So these are not technical details, but you can remember. Many manufacturers choose a battery for a vehicle that will supply the required cold cranking current when in the 80% charge condition at 7 degrees centigrade. So 7 degrees centigrade is also quite a less temperature. So at 7 degrees centigrade in the left side, you can say at 7 degrees centigrade, 80%. So how much is our power at 7 degrees centigrade? So our power at 7 degrees centigrade is almost 60%. Okay. So many manufacturers at 7 degrees centigrade, they choose that 80% of the charge should be there. So these are some details I am giving. No need to remember them. Okay, but only this graph you have to understand that at which place how much is the cold start limit people are keeping for which type of car, and different country, different temperature condition, and the cold start limit also changes. So that is one thing you have to understand. So this slide is very important. So they have given two conditions for choosing the correct battery for a vehicle. These two shown in green at the top is very important. So these are two important conditions. And second is to understand the graph. And I can generate my own graph and I can ask you in the exam. So please understand this graph. This is a very a simple slide, but it actually is related to the common sense that we have. That is where to position the battery within the vehicle. See, right side, this is not positioning. Right side, I have shown a Bosch battery of silver category, and these are the details. So I'm giving you a work. Just find out every point in it. So this is a homework for you. Next day when you are coming, I'll ask you. So just find what is meant by 4CT. Just find what is meant by 12 volt, 444 ampere hour, 450 ampere, En, what is meant by power control, what is okay, what is check, what is change, all these things you just find out. So go to the Bosch site or go to that one manual, lab manual PDF also I have given you. So it was uploaded, I think you have downloaded it of Bosch. So just go there and check the battery things and just find out what all details are made by this front panel of the battery. So there's a homework given to you. Please do that. Tomorrow I'll ask you about all this thing. What is meant by 4CT? What is 444AH? What is meant by power control system and other thing. This thing where to position the battery within the vehicle. Okay, so points to consider for the location of the battery within the vehicle. The first is weight distribution of the vehicle component. So battery is quite a bulky component and it's a very heavyweight component, and nowadays whatever batteries we are using, they are maintenance free. That means once they go bad, you just have to replace the battery. So there is no point that you have to you cannot rectify it, you cannot repair it. Okay, so but then also there are certain amount of things you can check. So we will see how to test the battery, what are the different things to be checked for a battery. So battery checking and all these things may be done, or maybe some uh, repairment or something. So accessibility is a very big issue in case of battery. It should be easily accessible by replacement. Protection against contamination. So there can be a lot of metal contamination. There can be a lot of pollutants and all these things, it might affect the battery performance. So we have to protect the battery from external contamination. There are two more protections required against ambient temperature and against vibration. Okay, so car is always a vibrating element, and vibration protection should be there. So kind of a cushioning effect we have to generate below the battery. So whoever is designing the car, they are actually giving all that cushioning effect for vibration protection. Ambient temperature is a very important parameter, because we have checked that if ambient temperature is less at that time, battery has to give maximum battery has to supply maximum power for car starting. So for very less ambient temperature, big power is required from battery. For high ambient temperature, less power is required for battery for starting. So that's why ambient temperature affects the battery performance to the highest extent. Weight distribution of the vehicle component and proximity to the starter to reduce the cable length. So there is a motor which is started initially by the battery, and before starting the motor, we have to start a starter. Okay, so all those starting system, charging system, we will be seeing in this chapter itself. So the battery should be close to the starter, because in that case the length of the wire should be less. If length of the wire is less, at the time power loss in the wire is less, because whenever some electricity is flowing through some wire, it is actually wasting some power. So that should not happen. That's why the proximity or closeness should be there between the battery and the starter of the motor. So proximity to the starter to reduce the cable length, very important factor. Weight distribution. So we have to keep the battery, or the designer has to keep the battery in such a position where the weight of the battery will be properly withstood by the car chassis or car body. It should not happen that the weight of the battery will damage the car. That should not happen. Okay. So all the other points we have discussed. So there's a very simple points, but each point we can think about how to control the ambient temperature. We should see that our car should not unnecessarily get heated up for anything. Okay, so unnecessarily whenever there is a jerk, whenever there is a bump, we have to be very careful, because all the heavy components inside the vehicle, they might get negatively affected by the jerk or vibration or bump. So we should be properly driving our car. And in the right side, the image is shown of the battery, and you should find out this part. So whatever is the front panel, each of the thing you are supposed to find out. 4CT, 12 volt, 44 ampere hour, other things. Most important thing, in the left hand side, I don't think this diagram will be asked in the exam, but if you can still check what are the components, or what are the physical constructional components of a Bosch lead acid battery. A cutaway figure is shown. So you can see there is post, there is plate strap, there is feed connector, terminal cover, and there is clamp, there is positive plate and installation, there is negative plate. So inside the battery, actually we are having two plates, and not two plates, but they are we'll show some construction diagram later on. So there are two plates, and inside that there is acid. Okay, so lead acid battery means PbSO4 will be there. So all those acids and the plates are metallic plates, so reaction happens between them. So we are finding cathode, anode. So positives get stored on some plate, negatives gets stored on some plate, and between the not connected positive and negative, we develop the potential, and that potential is actually used, and the load is connected between these 2 points, positive and negative of the battery, which are called electrodes. That is very important thing. So positive plate, negative plates are called as electrodes. Between them we connect the load and we get electricity. So that is the construction. That is, there should be two plates, two electrodes, and there should be acid. Very simply saying, it is like that. So after more than 100 years of development, I'm just going through the slide, and much promising research into other techniques of energy storage like fuel cell, there can be ultra capacitor, and many other different types of batteries. But mainly after 100 years of development also, lead acid battery is still the best choice for motor vehicle, because it can give very high amount of energy in very less time. So that is the main requirement for the starter or starting of the motor. very fast, there should be a surge or there should be an impulse kind of a response that the battery should be able to give to the starter. So this is particularly so when cost and energy density are taken into account. So energy density means or cost per unit energy. So how much value you are giving to purchase, procure that component, how much cost you are paying to procure that component, and how much unit of energy it is producing. So from there, per unit energy cost we calculate. So for lead acid battery, per unit energy cost is very low. That means it is taking very less amount of price and it is producing very high amount of energy. And that too with a very high rate. The rate means within very small amount of time, it can produce very high amount of energy. So these are the reasons because of which even after 100 years also, lead acid battery is the main battery which is connected for vehicle or car usage. So incremental changes over the years have made the sealed and maintenance free battery. So there are mainly again two types of battery. One is one we can open, we can put water in that distilled water, we can check by hydrometer how much is the charge density, SOC and all those things. So there is the unsealed type. Okay. Previously we used to use that, but now there are only sealed type. We won't have to replenish the water now and then. So incremental changes over the years have made the sealed and maintenance-free battery now in common use. Okay, and it is very reliable and it is very long-lasting. So it is totally maintenance-free. Once the battery is fit, permanently we have to use it, and it might go bad, we have to change it, and there is some life cycle, there is some lifetime calculations are there that we know that after a certain years or after a certain time we have to replenish the battery. So this may not always appear to be the case to some end users, but note that the quality is often related to the price. Okay, so sometimes we are getting very good quality at low price. Sometimes for getting good quality we have to give high price. But why lead acid battery? Because lead acid battery sealed type can give us very good energy quality with low price. So that is the buyer's dream, that we will pay least but we will get the best service or we will get the best performance. Okay, that's why this lead acid battery is very important. And sometimes some people will tell you that you just purchase this battery, this will be having warranty of 1 year. So what you'll find is 1 year it will run fine, but in the 13th month this will go bad. Okay, so we don't want that kind of thing. So that is what is written in the last line, that if you are having a guarantee of 12 months, in the 13th month the battery is going bad. And that is what we don't want. If we are getting a battery with a guarantee of 12 months, we'll be expecting that at least 3 years it will run without any kind of problem. Okay, so that's why lead acid battery is giving us this kind of characteristic, that though they are giving 12 months guarantee and all, but though things all it is running without any kind of hassles and generating proper electricity, and we are happy with it. So from performance point of view, lead acid battery is a very important thing. Pranita, you are not there, so I had set a rule, that is whatever underline we are doing, these are the very important things from the quiz point of view. So whenever you find some underline, that you must prepare. And it does not mean that if there is no underline, you will not prepare that. You have to prepare everything that I am giving in the slide. You won't have to even refer the book. Okay, the slides are very exhaustively made, and but whatever underlines are there, these are the very important things, and you have to prepare that. The basic construction of a nominal 12-volt lead battery. So in the previous slide, whatever Bosch battery I had shown, it was shown that 12 volt. So 12 volt is the lead acid battery that it can supply, and inside that there are 6 cells. So each cell they might be producing 2 volt each. So 6 cells connected in series producing 12 volt. So that is what is written here, and each cell is housed in an individual compartment within a polypropylene case. So that is another thing you have to remember. What is the case made of? So this is the outside, this is a case. This case is made of polypropylene component. So it's a plastic kind of a component, very hard plastic, reusable. Find that. This last paragraph is very important. That's what I have given it in a different color, and whichever things are given in bold and dark, and please prepare that and give more care for those part in the slide. So the active material is held in grids or baskets to form the positive and negative plates. So some you can check. I have just checked yesterday in Google. I have not put all those images here because it would have made the presentation more bulky, more uh, complex. Okay, but you can check how the baskets or how the positive and negative plates inside a Bosch lead acid battery of present type. Present type means sealed type. Okay, how does it look? Okay, so separators made from microporous plastic insulate. So each of this positive negative, they are separated, and there are microporous plastic insulate which are separating these plates from each other. But the liquid, whatever is there inside, that can touch both positive and negative. So uh, liquid, through liquid they are shorted, but otherwise there is some isolation. The grids connecting strips and the battery posts are made from a lead alloy. So what is post? You can check here. So this is the post, okay, which is there at the corner of the battery, and we take out connections from it. Okay, so these connections are actually made from lead alloy. Many years this was antimony. So PBSB, lead and antimony, they were combined. SB is for that. Lead and antimony, they were combined. Posts were made of that, but nowadays they are using lead cadmium, PBCA. Okay, so evolution is continuously happening. You can see at the top of the slide that last 100 years the development is happening in this lead acid battery. So from lead antimony, now we are using lead cadmium. Okay, so there are a lot of underlines in this slide. Please go through, and if they are asking the construction of lead acid battery, these are the things. If you write, it will be okay. And then the different four events that is happening inside the lead acid battery is shown here. So you can see the image at the top. In the left side, it is called as fully charged. Fully charged means on the left side, this plate, dark brown plate, all the charges may be positive, and this gray plates, all the negative charge, they are stored. And if you check between these 2 points, between the two electrodes, highest amount of potential difference is created. Why it is called potential difference? Because they are not connected. Okay, but in the second case, we have connected this positive and negative electrodes through a load. Okay, whenever we are connecting it through a load, means electricity is flowing from the positive to negative, or electrons are flowing from the negative to positive. So in this case, actually this is the use, whenever we are using that electricity. So what is the total diagram called? It is called battery charging and discharging process. Okay. So second thing is discharging, means we are actually extracting all those charged energy from the battery for our usage. Okay, so this is the second step where the usage is happening. Third stage, it is called charging. So charging means this is G. So this in that case actually gassing occurs. Gassing means we will see the equation of lead acid battery, and we will be finding that hydrogen, oxygen, all those things are liberated, and that gassing is something which is again a very important factor. We have to be careful in case of any battery. So gassing, actually huge amount of gas produced, hydrogen, oxygen and all, they actually create a lot of unnecessary pressure inside the battery. That's why they used to keep some opening in the previous type of battery, not now, not the sealed type. Previously, whatever unsealed type was there, there used to be some kind of pressure release kind of things there. But nowadays, they are all sealed. So we see, or we make it a point that gassing is not too much. Okay, so this is the charging part and this is the gassing part. They are actually a combined process, charging and gassing, because during the charging part, the gassing occurs. And after the charging, it again comes to this first diagram, which is called fully charged. And in fully charged, again, the positive and negative ions are there in two different electrodes. So if you are asked, you can explain this part of a battery charging and discharging process. So the newer material PBCA, that is the lead calcium, it was shown lead calcium in the previous slide. So the newer material PBCA, it caused less gassing. So that is what I am telling. Previously they were using lead antimony. Nowadays they are using lead calcium. So lead calcium is causing less gassing of the electrolyte when the battery is fully charged. This has been one of the main reasons why sealed batteries become feasible, as water loss is considerably reduced. So previously, a lot of water used to be produced. Previously, lead antimony, a lot of gas were produced. But by using lead calcium, we have reduced the water release or water production as well as the gas release during the gassing process. So this is a very big change, lead antimony to lead calcium. And what change it has done, it is given in this paragraph. However, even modern batteries described as sealed do still have a small vent. Just see, this is the pressure release to stop the pressure buildup due to very small amount of gassing. So even there is a very small amount of gassing that occurs during the charging or gassing process. We want to avoid that because any amount of gassing inside the battery, it creates some pressure, and that pressure actually releases actually is reduces the energy generation. It affects the energy generation negatively. So there is a small vent, so it's a kind of a path through which the excess gas actually comes out of the sealed battery also. So the sealed batteries still have a small vent to stop the pressure buildup due to the very small amount of gassing. A further requirement of sealed batteries is accurate control of charging voltage. And right side you can check what is the battery grid before the active material are added on it. So this is a metallic grid what they are showing, and on that actually they are putting a lot of active materials, and that is producing the electrodes. Okay, so details of these diagrams you can go through the site of Bosch or any battery website and you can find out. Okay, so this is not the scope of the syllabus, that's what I am not explaining that. Okay, so what is meant by battery rating? So now I'll go a little faster. The characteristics of rating of a particular battery are determined by two things. That is how much current it can supply, how much current it can produce, and second thing is how long it can produce this current without any kind of problem, without any kind of fluctuation. So two things are mainly there for battery rating: how much current it can produce, that is the first thing, and how long it can sustain producing the same amount of current without any kind of drop. Okay, so these two are the things which are deciding the battery rating. The rate at which the battery can produce current is determined the speed of chemical reaction. So inside the battery, if the chemical reaction happens very fast, chemical reaction means that production of positive, negative ions and depositing on the battery electrode, and from the electrode we are extracting the positive and negative ions through the load, and that is actually causing the current flow. So how fast that positive negative ion can be produced, can be deposited on the electrodes, and how fast they can be taken out through the load from the battery, all these things are deciding the rating of the battery. So the rate at which the battery can produce current is determined by the speed of the chemical reaction. And these are the very four important things. You can take these four things into your brain now itself, that what are the things that are determining the rating of a battery. So first thing is, what are the electrode surface? Plates means electrodes. What are the electrode surface? So more is the electrode surface, more will be the deposition of positive and negative ion on it, and more will be the charge that will be able to extract from the battery. So first one is the surface area of the plates. Second one is what is the temperature. So from the beginning of this lecture only I am telling you, more is the temperature. More means not very high. Okay, more means moderate. 20 degrees centigrade, 30 degrees centigrade, good enough. But the same thing when it becomes 40, 50, the battery performance deteriorates. The same temperature when goes to minus 30, minus 40, again battery temperature deteriorates. But if the temperature is 0 degree, 10 degree or minus 10 degree, it's okay. It's a moderate range for battery operation. So battery rating is determined by surface area of the plate. More is the surface area, more will be the charge produced, more will be the energy extracted from the battery. Temperature very less is bad, very high is bad. So temperature range was minus 30 to plus 70. Pranita, you are not there, we have discussed it, remember that range. Okay, and mid range is around 10-20 degrees centigrade. This is the best range for battery operation. Electrolyte strength. So whatever electrolyte we are putting in on the electrodes and all, or electrolyte is actually the liquid. What is the strength of that? Very high strength. We feel that will produce a lot of electricity. It's not like that. There is a certain strength of the electrolyte that will give us optimum electricity production. So we have to use that. and the current demanded from it. Certain times the battery is loaded. It cannot supply that much current, but the car or vehicle, maybe the engine has become very old, but the vehicle is asking for too much power from the battery. That battery cannot supply it. So continuously, too much power is extracted from the battery, too much power is demanded from the battery actually degrades very fast. That's why it is said that whenever we are using some device with battery, let's say nowadays we are not using camera and all because mobile phone does that job. But previously, whenever we used to use some digital camera and all, it was written on there. As soon as the battery is exhausted, take out the battery and recharge it or put new cell. Because if we are putting a discharged battery in the system and we are trying to extract power from that, that actually damages the whole battery and the whole electronic system as well. So current demanded from the battery is a very important thing, and the current demanded should not be unnecessarily high from the battery. In that case, it will damage the battery. So the actual current supplied therefore determines the overall capacity of the battery. So this is another important thing. How to determine the capacity of a battery? So how much current we are demanding from the battery, that is determining what is the overall capacity of the battery. So rating of the battery has to specify the current output and the time. So there is coming one very important concept which is called as AH, capital A small h, which is called as ampere hour. So how much ampere the battery can produce continuously for how much hour? So if the battery is producing 2 ampere for 2 hours, okay, in that case we say ampere hour rating is 2 into 2, that is 4. Okay, so that is the ampere hour rating. If you check the Bosch battery diagram which I had shown you, it was having ampere hour rating of 44. So that is the standard Bosch battery for vehicle, 12 volt, 44 ampere hour. 44 ampere hour means for 11 hour if you are running the battery, it will be giving you 4 ampere. But generally standard time is 20 hour. Okay, so ampere hour is determined for the period of 20 hour. It is said that the method describes how much current the battery is able to supply either for 10 hour or 20 hour. Don't see at 10 hour, check at 20 hours only. So if a battery for 20 hours, it can give you 2.2 ampere current, then we can say that ampere hour for the battery is 2.2 multiplied by 20, that is 44 ampere hour. So that is what example is saying. The Bosch battery which I had shown you previously, it was having 44 ampere hour rating. It means that if fully charged, so first the fully charged has to happen, battery should be 100% charged. If the battery is 100% charged, then for continuous 22 hours, for 20 hours, it can give us 2.2 ampere current. Constant current of 2.2 ampere it can give us for 20 hours before it is completely discharged, and this is also a very important rating, before it comes to 1.75 volt. So this is the discharge voltage, very important thing, remember. So whatever was the initial voltage 12 volt, it is fully charged, it will give us 2.2 ampere for 20 hours, and the whole battery will discharge to the lowest voltage level of 1.75 ampere. Can you see there are two stars in this slide number 7? Very important slide. Everything in this slide is important. So what is the highest voltage? 12 volt, 100% charged. For 20 hours, it can give us 2.2 ampere. That is 44 ampere hour. Ampere hour is the rating of the battery. It is called power rating. 44 ampere hour. And after it is supplying 2.2 ampere for 20 hours, then it will completely discharge to 1.75 volt. So that is the lowest voltage. Again, you have to start charging the battery. So there are three very important definitions which will come in this slide. There is a battery rating. One is what is the ampere hour rating. Ampere hour rating is 44 ampere hour. Second is reserve capacity. So, and third one will be CCE, that is cold cranking ampere. Okay, so let us see what is meant by reserve capacity. So we are entering now towards a more technical part of this topic, that is the battery. So what is meant by reserve capacity? A very important definition you must prepare. So a system used now, so at present system, all new batteries is having a reserve capacity. What is reserve capacity? This is a time in minutes. So previously ampere hour rating was in 20 hours, but reserve capacity is in minutes, for which the battery will supply 25 ampere at 25 degrees centigrade to a final voltage of 1.75 volt per cell. So what is the initial voltage of the battery? Initial voltage is 2 volt per cell. Okay, 12 volt is for 6 cells. Okay, each battery is having 2 volt per cell before it is or after it is fully charged. And then when from 2 volt it is fully charged, then it will be able to supply 2.2 ampere for 20 hours. And after that it will get discharged up to 1.75 volt. This is the case. That was in case of ampere hour rating. In case of reserve capacity, every battery will be charged 2 volt, but it will not wait for 20 hours. In that case, what it is saying is typically a 44 Ah battery will be charged for 60 minutes. That means in 60 minutes time, that is in 1 hour time, whatever is the high current it can supply. How much is that current? It is 25 ampere. So after getting fully charged, if you are running the battery for 20 hours, it will be giving you 2.2 ampere. But if you are charging the battery fully up to 2 volt, and if you are running it at a higher capacity means 25 ampere, and if it can give 25 ampere for 60 minutes or 1 hour, then we can say it is having a very good reserve capacity. So difference between ampere hour and reserve capacity. So ampere hour is for 20 hours. After getting fully charged, that is each cell is getting charged up to 2 volt. Overall battery is getting charged for 12 volt, and they are supplying 2.2 ampere for 20 hours. And after that, each 2 volt battery is getting discharged to 1.75 volt. This is all about ampere hour. Reserve capacity means the same battery, we are not running for 20 hours, but we can do a accelerated testing whether it can supply very high current for small amount of time. Yes, it can. And how to test the reserve capacity? 2 volt fully charged, 25 ampere if you can extract from it at 25 degrees centigrade for 1 hour. And after that battery comes to the discharge state. What is the discharge voltage of battery? 1.75 volt per cell. Then we can say it is having a good reserve capacity. Last example is cold cranking amps. Cold cranking amps means whenever the battery is totally in a very less ambient condition, then in a not for 20 hours, not for 60 minutes, but in 1 minute, we will check the accelerated testing condition of the battery. So cold cranking amp means in 1 minute how much the current that the battery can supply. And for this batteries of 44 ampere hour 12 volt, we are checking that we are expecting somewhere around 170 ampere from that battery at very cold ambient temperature. So cold cranking amp, it is called as CCA. Batteries are given a rating to indicate performance at very high current output and a very low temperature. So in the lowest temperature, how much maximum current it can supply. That is actually telling us about cold cranking ampere. So a typical value of 170 ampere means that the battery will supply a current of 170 ampere for 1 minute, and it will get discharged to 1.75 volt. And what is the temperature? 18 degrees centigrade temperature or less, and at which the cell voltage will fall not to 1.75 volt but 1.4 volt. That means huge amount of discharge we are doing from the battery. In 1 minute we are continuously getting 170 ampere from that, and the battery is discharging from 2 volt to 1.4 volt. So these are the three very important ratings of a battery: ampere hour, reserve capacity, cold cranking amp. Very religiously prepare these three definitions, and we will be getting a graph. So you can see there are three graphs. So overall output of battery is much greater for 1 hour time. Okay, that means for 20 hour we are going to get 2.2 ampere. But the same thing, if you are reducing the time to 1 hour, we are getting a lot of a lot of greater current, that is 25 ampere. Still we are reducing the time span to 1 minute, and we are getting 170 ampere. Okay, so this is a very important graph you have to prepare for exam. Figure below compares the three types of discharges. This is the first type, 2.2 ampere for 20 hour. This is called as the first type, ampere hour rating, and y-axis is state of charge, x-axis is time. 25 ampere for 60 minutes. This is called previous side. You can check reverse capacity. And last one is the cold cranking ampere. This is for 1 minute and 170 ampere. So before all the batteries they are brought into the market, all these three things, all these three discharge ratings are tested for any battery, and then they are brought into the market. So these are battery rating for discharge characteristics. Summary of all these three characteristics, you can say capacity of a battery is the amount of electrical energy that can be obtained from it. It is usually given in ampere hours. So this is one type of rating. Reserve capacity, that is 25 ampere over 1 hour time. Cold cranking ampere, this is 170 ampere for 1 minute time. So all these three things are satisfied and we say battery rating is perfect. So I am stopping now. We are in the middle of the slide number 8 and main things are covered. If you are having any doubt, you can ask, or else we can stop the session here.